Islamic astronomy represents one of the most significant chapters in the history of scientific advancement, flourishing primarily during the Islamic Golden Age. During this remarkable period, astronomers in the Islamic world made extraordinary contributions that not only preserved ancient knowledge, but substantially advanced the understanding of celestial phenomena. Their work formed the foundation upon which modern astronomy would later develop, creating a scientific legacy that continues to influence our understanding of the cosmos today. Prior to the rise of Islam, Arabs relied upon empirical observations of stars based on a constellation tradition known as Anwa, which tracked the rising and setting of particular stars. This indigenous knowledge was transformed after Islamization, when Arab astronomers introduced mathematical principles to their observational practices, creating a more sophisticated approach to studying the night sky. The evolution of Islamic astronomy began with the translation movement under the Abbasid caliphs, particularly Al-Mansur and Al-Ma'mun, who established Baghdad as a major center of astronomical study between the 8th and 10th centuries. During this period, scientists translated astronomical works from Sanskrit, Pahlavi, and Greek into Arabic, creating a comprehensive body of astronomical knowledge that would serve as the foundation for future innovations. The earliest astronomical texts translated into Arabic were of Indian and Persian origin, including Zij al-Sindind and Zij al-Shah. These translations were spearheaded by scholars like Muhammad ibn Ibrahim al-Fazara and Yaqub ibn Tariq after 770 CE, with the assistance of Indian astronomers present at the court of Caliph al-Mansur. Ptolemy's Almagest, presenting a geocentric model of the cosmos, was translated at least 5 times in the late 8th and 9th centuries, becoming a foundational text in the Arabic astronomical tradition. This translation activity demonstrated the Islamic world's commitment to synthesizing diverse astronomical traditions into a unified body of knowledge. The development of Islamic astronomy was significantly motivated by religious requirements. Islamic practices necessitated the precise determination of the 5 daily prayer times, the Qibla, and the appearance of the new moon that marked the beginning of each month. These practical needs stimulated intellectual progress in the field, leading to more refined observational techniques and calculation methods that would ultimately benefit astronomical science as a whole. A distinctive feature of Islamic astronomy was the establishment of observatories and the institutional support provided by various rulers. The first systematic astronomical observations in the Islamic world occurred under the patronage of Caliph al-Ma'mun in the early 9th century. From Damascus to Baghdad, observatories conducted detailed observations of celestial bodies, performed meridian degree measurements, and established solar parameters that enhanced understanding of our solar system. The 10th century witnessed increased support for astronomical research under the Buwayhid dynasty, which encouraged the construction of large-scale instruments for astronomical observations. During this period, the renowned astronomer Abd al-Rahman al-Sufi systematically revised Ptolemy's star catalogue under the patronage of Prince Adud al-Dawla, making significant corrections to the positions and magnitudes of stars. Similar observatories emerged in Baghdad under Sharaf al-Dawla, while reports from Ibn Yunus and al-Zarqali in Toledo and Cordoba indicate the use of increasingly sophisticated instruments. The establishment of the first large observatory by Malik Shah Bursh, likely in Isfahan, marked a significant advancement in Islamic astronomy. At this institution, Omar Khayyam and numerous collaborators constructed astronomical tables and formulated the Persian solar calendar, a version of which remains in official use in Iran and Afghanistan today. This demonstrates how astronomical knowledge directly influenced timekeeping systems that continue to shape modern societies. Islamic astronomers significantly advanced the development and refinement of astronomical instruments, enhancing their precision and usability. Our knowledge of these instruments derives from surviving artifacts in collections worldwide and from treatises preserved from the medieval period. Muslim astronomers improved existing instruments by adding new scales and details, thereby increasing their accuracy and range of applications. Among the most notable instruments were celestial globes, primarily used for solving problems in celestial astronomy. Of the 126 such instruments that remain worldwide today, the oldest dates from the 11th century. These globes allowed astronomers to calculate the altitude of the sun or the right ascension and declination of stars by positioning the observer's location on the meridian ring. The conceptual blueprint for a portable celestial globe to measure celestial coordinates originated with Spanish Muslim astronomer Jabir ibn Aflah. The astrolabe, one of the earliest instruments developed and perfected by Muslims, played a crucial role in astronomical calculations and observations. This flat circular device helped astronomers determine the position of celestial objects and solve problems related to time and the position of the observer. Al-Khwarizmi described various types of quadrants, including the sign quadrant, which were widely used throughout the Islamic world to solve problems of spherical astronomy for any latitude. Al-Khwarizmi made significant contributions to instrumentation by constructing the al-Suds al-Fakhri for measuring the ecliptic. His innovations allowed for the measurement of minutes and seconds, whereas previous instruments could not indicate seconds with such precision. He also developed a universal instrument called al-Ala al-Shamila that could be used instead of the astrolabe or quadrant and was adaptable to any latitude. Beyond instruments and observations, Islamic astronomers made substantial theoretical contributions to astronomy. They developed comprehensive astronomical handbooks with tables known as Zijaz, which contain mathematical instructions for calculating the positions of the sun, moon, and planets. A survey identified approximately 125 Islamic astronomical handbooks, with tables prepared in Muslim lands between 750 CE and later periods. These Zijaz represented a unique Islamic expansion of astronomical methods and concepts starting in the 10th century. They evolved from initial influences of Greek and Indian traditions into distinctive Islamic approaches, with important sub-traditions developing in Al-Andalus and the Maghrib. The continued refinement of these tables demonstrated the Islamic astronomers' commitment to increasing the accuracy of astronomical calculations. Ibn al-Haytham's Hayat al-Alam on the configuration of the world was perhaps his most ambitious and influential astronomical writing. This work explained basic astronomical concepts such as longitude, latitude, and altitude, and discussed mathematical geography. His approach attempted to reconcile the geometry of mathematical astronomy with the three-dimensional physical model endorsed by natural philosophy, creating a more integrated understanding of the cosmos. The legacy of Islamic astronomy extends far beyond the medieval period. A significant number of stars in the sky, such as Aldebaran, Altair, and Deneb, and astronomical terms such as Alidad, Azimuth, and Nadir, continue to bear their Arabic names, attesting to the enduring influence of Islamic astronomers. This linguistic heritage reflects the fundamental contributions these scholars made to our understanding of the celestial sphere. Islamic astronomical knowledge also had practical applications in maritime navigation. Ahmed ibn Majid, a Muslim navigator, guided Portuguese explorer Vasco da Gama in establishing the first sea trade route from Europe to India in the mid-15th century. The cartographic and astronomical contributions of figures like Al-Battani and Piri formed the foundation of astronomical navigation that would facilitate global exploration. The scientific innovations of Islamic astronomers were transmitted to Europe through various channels, including the Crusades and trade relations. These contributions significantly influenced Western scientific development, though they are often overlooked in favor of Greek works. A large corpus of literature from Islamic astronomy remains today, numbering approximately 10,000 manuscripts scattered throughout the world, many of which have yet to be studied in depth. The contributions of Islamic astronomers to astronomy were multifaceted and profound, from the translation and preservation of ancient knowledge to groundbreaking observations. From the development of sophisticated instruments to theoretical innovations, Islamic astronomers advanced our understanding of the cosmos in ways that continue to resonate today. Their achievements, motivated by both practical needs and intellectual curiosity, represent a remarkable chapter in the history of scientific endeavor that deserves greater recognition as foundational to modern astronomy. The synthesis of diverse astronomical traditions into a coherent and expanded body of knowledge stands as one of the most significant intellectual achievements of medieval Islamic civilization.